Now, that's what it's telling me. So, it's the derivative of the velocity function, or the second derivative of the position function. In this case, it's equal to what?
2.
Yeah, the derivative of this. D dt both sides. Again, follow the same rules. You see how it follows the same rules, as an x? It's the same rules, only it's just a t. As long as it's d dt, d dx, that's what is the variable that's going to follow the rules, okay? So, acceleration, let's graph it, is equal to the derivative of velocity, is equal to the second derivative of position, which is 2 I'm only on this interval. Okay? So, this is my right and left example. I'm going to show you an example of up and down. You guys ready? Okay. Tell me what happens. What just happened? Before that. Okay, well here's the fancy word. We got an acceleration down. What happens in the beginning? Give me the whole process. Well, there's so much stuff, action in there. Guys, we lost it. We have a cap down.
It went up first. Didn't it go up?
So what happens at the beginning? I threw with a constant velocity, just like a bing. So what's my velocity to start?
Would it be 10?
Positive or negative? Let's give it 10. But then what happens at that 10? Why is it slowing down? Gravity is a what? Or an acceleration. A gravity is an acceleration. That's screwing around with your velocity. What's the sign on acceleration? Does acceleration force things down or shoot you into the air? Negative. Yeah, the acceleration on Earth is negative. Again, if we assign positive is up and negative is down, that acceleration is going to be down. Does that make sense, Rafi? It's just like here I was assigning positive is right, negative is left. But in either case, I can only go, whenever I do any example, it's either going to be just straight up and down or just right and left. Okay, I'm not going to do any like swirly cues on you. Okay, Roxana? Okay? So let's check out what's happening here. On the way up, what's the velocity, what's the acceleration in terms of sign? Is the velocity positive or negative? Positive. And is the acceleration positive or negative?
Negative.
Yeah, velocity is positive. I shoot it up. And the acceleration is constant on Earth at 9.81 meters per second or 32.2 feet per second squared. But then what happens? So it stops instantaneously. What's the velocity up there? What's the acceleration?
Negative 9.
Still constant. And then what happens on the way down? The acceleration is constant. But what is speeding up? Why? What's the sign on the velocity? Velocity is negative. What's the sign on acceleration? What's the sign on acceleration? The acceleration on Earth is always negative. It's constant. Negative 9.81, negative 32.2. On the way up, what's the velocity? What's the acceleration?
Negative.
On the way down, what's the velocity? What's the acceleration? On the way up, are you speeding up or slowing down? On the way down, are you speeding up or slowing down? Here's what happens. When the signs are the same, you're going to speed up. And when the signs are different, you're going to slow down. Does that make sense? If you're traveling in the negative direction and something is accelerating you in the negative direction, you're going to start going faster in that negative direction. Does that make sense? And the same thing is true as right or left in the positive direction. If you're going in the positive, and all of a sudden if I'm going this way and I accelerate, I hit the gas, I'm going to speed up. Does that make sense? You know, if I'm going this way and I hit the brake, there's a slowing down, there's a negative acceleration. You're going to be speeding down. Does that make sense? Signs are different, you're slowing down. If the signs are the same, you speed up. If the signs are different, you slow down. Does that make sense, you guys? So let's take a look at what happens here. What happens from 0 to 3 seconds? According to this graph, and according to this graph. Yeah, what's happening from 0 to 3 seconds as far as speeding up and slowing down? Looking at this graph, my velocity graph, and looking at my acceleration graph. Why are you slowing down? Yeah, so one way to look at it is exactly how you were earlier, Katie. It's like this is getting closer to the x-axis, so that's how you know you're slowing down. And as you go right and you get away from the x-axis, you're speeding up. Or here you have a negative velocity and a positive acceleration, so you're slowing down. Does that make sense? Here, after 3, you have a positive velocity and a positive acceleration. What does that mean? It means you're speeding up. Does that make sense? A couple different ways to look at the same information. Again, what exactly as Katie said is, if you approach, as you go right, so as time goes on, if you're approaching the x-axis, you're slowing down. Either like this or like this. Does that make sense? And if you're going away, you're speeding up. Like here, we're speeding up. Okay? Does that make sense, you guys? Now that's looking at a velocity graph. Now I have 3 different graphs on the board here. And they all tell you different stories. They give you different information. And the tricky part is going to be figuring out what we're looking at and then what information we can get off of it. Okay, does that make sense, guys? Alright? So let's try this one. So flip your notes and let's look at this little graph. Chris, read those up for me. Yeah. I think it's like 2 pages in. It's a nice little graph that goes up and down and all this other good stuff. Looks like this guy. Alright, so take a look at this thing. You guys see it in your notes? Yeah? Okay. What is this a graph of? What is this a graph of? This is a velocity graph. The input is time and the output is velocity. Yep, you should always look for that first to know what you're looking at. Okay? So according to this graph, when are you moving to the right? During what time intervals?
0, 1, 5.
Why are you moving to the right from 0 to 1 and 5 to 7? Yes, because if you're looking at a velocity graph, you're moving to the right when the velocity is positive. Does that make sense, you guys? Okay, now change that little V, Chris, to an S on the top. You don't have to literally, just think about it in your head. If this is a position graph, when are you moving to the right?